Welcome to the DSPy interview series show, everyone. If you've read the papers on recursive language models and wondered how do you actually build one and how do you use one, today's guest has the answers. I'm joined by Issac Miller, a core contributor to DSPy. Issac is the engineer responsible for the DSPy RLM implementation, the code that basically enables model to recursively query, split, process infinite context using the RLM loop. Issac has a serious pedigree in the space. He has previously worked as a machine learning engineer at Normal Computing and Anyscale as an intern. He's done both his master's and bachelor's degree in computer science from Northwest. And he also happens to be the sixth top contributor to the DSPy code base. Hey, Issac, welcome to the show.
Hey, thanks for having me.
It's pretty awesome to have you with us, especially today, because DSPy weekly issue is just focused on, the RLMs. And it's such a coincidence, getting to talk to you today. So Issac, tell us a little bit about yourself and, how did you become a contributor to DSPy? How did it all start?
Yeah, so about two years ago, I was in the middle of doing my master's and I needed to write a thesis. And I think I just saw a tweet from Omar about DSPy. And I said, oh, this is cool. And so I went and then I saw some typo in the README. And that was kind of my first like open source contribution ever. And then I looked at the library, I saw that, oh, hey, they have tests, but they're not, running them in C. And I was like, I don't know much about AI yet other than from my courses, but I've written a CI pipeline. So I wrote a GitHub action. And then I started talking to Omar more and kind of getting involved with some of the like fine tuning and reinforcement learning sides of DSPy, and then just kept on contributing from there.
Got it. Okay, awesome. So, let's talk about RLM. It's all the buzz off late, and you're the man to talk about it. So how do you define RLM and, how does it work and what is it about?
So the core idea behind an RLM is that it can act on its inputs programmatically, which really means it has access to some programming environment. It doesn't have to be Python. For DSPy it is. And it can manipulate its inputs using the code that it writes, which means that you can kind of have the decomposition be done by the model in real time. So if you pass in a really long document, it can decide to split it up into however many chunks and then do whatever it needs to do to each chunk and then aggregate the results at the end. And kind of this decomposition can be whatever the model decides is the best way to do it without actually having to read all of the context into its main context stream.
Got it. So the model is effectively both the planner and the executor. Can we put it that way?
It's the executor and also, but it can execute symbolically, which means that it can write code. So it doesn't have to, do all the summarization itself.
Right. But as an executor, as in it is deciding what is the subtask and it is deciding when to pause, when to call it, and sort of continue, correct? So what's the key difference between, let's say, the implementation Alex has, that is his RLM library, versus what we have in DSPy?
So I think the key difference is that DSPy is based around signatures, right? Signatures are kind of the core unit in DSPy. And so because we are doing everything based around signatures, you have structured inputs, structured outputs, and a task description by nature. And so when you think about kind of what should the model have access to programmatically, it doesn't really need programmatic access to the task description. And for the different input variables, it should have those as separate variables. And for the output variables, they should be the types that you enforce. You have them as not, if they're a list, they should be a list. And so DSPy allows you to actually enforce these constraints on the model, give it better structure, and allow it to match your task better.
Got it. So off late, there is a lot of buzz, at least on Twitter, on what's RLM is good for and what it isn't, where you should apply. So I've got a bunch of, scenarios. And I was wondering if I could sort of put those scenarios in front of you and you could tell us whether a standard LLM makes more sense or... and I think it also, so this exercise effectively helps do away with some of the misinformation and also guides people into the use cases where RLMs would shine. So you game for this?
Yeah, okay. Let's do it.
All right. So let's take scenario one. I've got 10 million server log file. Okay. And I need to find the exact timestamp for an IP address and see if it got like timeout error. So should I go with a standard LLM or an RLM, and why?
Here, I think it's an RLM. It's a really long file, right? RLMs are great for long context, and it's kind of a simple regex you need it to write. So either write the regex yourself and run it, or pass it to the RLM.
Okay. So this use case is RLM. Let's take another example where we sort of have a larger file, let's say a 500-page novel. Now, however, the user wants to know, does the overall mood of the book feels more like a 19th century Russian literature, or is it a modern science fiction?
Yeah, I mean, this one is also, 500 pages is pretty long, so you can lean RLM, but
Okay.
also kind of depending on the book, maybe the overall mood really needs to see all of the context at once, which if you need to see all of the context, then maybe you want a standard LLM. If you can kind of decompose by chapter or by page and then summarize and aggregate, then an RLM could help here.
Got it. Does it make sense that you sort of split and keep picking the mood per sort of segment, and then finally you have this one composite list, and then you just take that and sort of maybe give it to an LLM and ask what is the overarching sort of theme, or and sort of do both, or you feel even the second segment can go back to an RLM, maybe as a different execution?
Yeah, I think if you trust the RLM to kind of figure out the right decomposition, then in theory it would do both steps. Or you can, if you're using a weaker model, you can force it to do this multi-stage where it gets all the, chapter by chapter descriptions,
Got it.
and then afterwards you pass that to a separate stage.
So the right segment size would make a difference, right? That's it.
Yep.
Pretty much. Yeah. Okay.
Depending on how strong your model is.
Understood. How about like a standard 50-page marketing document which some sales guy puts in and says, "Hey, make this more punchy and energetic." What works for that?
Yeah, I mean, 50 pages is long. I think because you want to rewrite the document not page by page, right? It needs to be kind of a sequential thing that flows together. I would lean towards some more standard LLM approach here.
Okay.
Because you just don't gain much by hiding context.
I've got a bunch of don'ts or where RLM doesn't fit well, and you can let me know if I got that right. So let's say if somebody is doing like a real-time chat, right? And they want to give really quick responses to the user. I think maybe RLM wouldn't be the right fit because it might take the loop more time to finish. So that's sort of my thought process there. And you can you can just stop me anywhere where you think you want to add anything. Second is obviously the shorter documents where the standard context window is fast, cheap, and simple. Third, I felt that wherever you have abstract queries or sort of vague queries, right, or things like, I mean, it'll be probably harder for the RLM versus a vector DB based query. So I'll take a pause here. Is it the same sort of mindset for the last conversation that we had? Like,
yeah, I think that if an LLM could answer it and kind of you need to figure out the decomposition on the fly, then figuring out whatever vibe means, an RLM could do that. But there's also great cases to not use RLMs for situations like that.
Understood. Okay. And the last one being is that, which I think you've already answered, that if you have a very weak base model, right, and it cannot reliably do regex, write Python, then RLM execution probably will have a lot of errors or might not even work. So would that be also correct? Okay.
Exactly.
And can you tell me, tell our audience which are the models that should do well, frontier models?
Yep. So GPT-5 is my standard go-to. And then I've heard good things about Quencoder. I've heard that Kimi can do this pretty well. And then also I would have to imagine that the frontier models from, Google, Anthropic, your Opus 4.5 and Gemini can do this fine. I haven't tried them, but I'm sure they can.
Got it. Understood. Okay. This was super helpful. So how about, is it possible for you to, sort of walk us through your RLM implementation and on a high level and just show our audience how it works?
Yeah, absolutely. Let me share my screen here. Awesome. So let's, the way that both RLM and React and DSPy work is that we take the signature that you pass in and we use that to actually create sub-signatures. And so what we do is we create an action signature, which says, hey, we're going to take your inputs and we're going to output some code from them as opposed to your original outputs. And then we have an extract signature, which says when you have reached the maximum of iterations, you're forced to output something. So those are the base signatures that we're using here. And then when you actually call the RLM,
That is forward?
that is forward, yes. So
Okay.
when you call the RLM, it builds kind of the tools you need. It passes in the variables that you need to use. Because, like I said earlier, it's just very important that the model has access to different variables for each of your inputs.
One quick question. When you said the tools you need, are you talking about the whole sort of tool chain that goes till Dino?
So in this case, tools refers to functions that you want to pass, callable
Okay.
functions that you want to pass
Okay. Got it.
to the
Understood.
RLM.
Okay.
And you can pass anything. By default, you pass the sub LLM
Okay.
tool.
Got it. Because it just tells you what to execute, what tool, and when you're executing the tool, the whole Dino thing works as normally, like it does, right?
This is how the Dino thing works. So what happens is that we spin up a local Dino sandbox that uses WebAssembly to run Pyodide inside of it. So we have Python running in our host, JavaScript in between, and then Python on the WASM instance. And so we use that, and basically we just keep generating code until, so this is this execute iteration function, which, so we just keep generating code. We run this function until we complete. We generate an action, which an action has our code and reasoning inside of it. And then with this action, we execute the code inside of the REPL, and then we return this result. And then back in our forward loop, we have this result, and we just keep looping through it until we hit max iterations or we get a prediction out.
Got it. Understood. What's the default for max iteration? Just curious.
I think 20.
20. Okay. And is it dynamic in the sense that when the input comes, do you kind of change that, or it just stays constant at 20 and the user needs to drive it?
It stays constant at 20.
Okay, understood.
Like, I think 20 is a safe default, and if your task is really long or you see that it's running out of iterations, then you can change it.
You can change it. Okay. Another quick question, like, how do you determine like how many chunks to split the input context into, or the, yeah.
So we don't split the input context into chunks. We split it based on the input variables of your signature.
Okay.
So if you have a 10 million token variable that you're passing through, that would just be a 10 million token variable inside of the REPL. There's no chunking that happens.
Oh, okay. So because it's on the computer side, do you pass like some sense of size, etc., to the model, or nothing?
Yep. So when we're describing the variables to the model, we have a REPL variable here, and this will actually just tell the model some things about this variable and give it a little preview, and then it can figure out if it wants to investigate it more.
Understood. So the model determines the start and the end that it's looking to investigate. That comes back. Then somewhere it has to be chunked, right? Then it happens at the sort of at the client side where you're running the DSPy RLM code just before in the sandbox. Is that correct?
What do you mean it has to be chunked?
Okay, so let's say I've got 10 million tokens. Obviously, I'm not passing that to the language model somewhere. So now that you have that file, so the chunk, what do you call, the start to end will be done by the Python code that was generated by the language model, correct? Okay, so I just wanted to understand the whole flow. So that's what I meant by chunking. Understood. So it is, I just keep forgetting, it's the model which is in the driver's seat here entirely.
Yeah. Okay. The model controls it all.
I've got one more question for you, Isaac. So while I ran RLM and I sort of got a quick sense of things, one thing I wanted to know was, so let's say I've got ML flow integrated, right?
Yeah.
Would I be able, like, how would I see this execution? Like, would it be like you're in GEPA, etc., when, the traces are happening? it sort of all gets nested inside like a common execution. Is it the same way? Would I be able to see all the history of each and every iteration? Or is it like just one combined execution? How does that look like?
We're still improving. This was a little buggy when we were releasing it, but I can show you. I have an ML flow trace here, which you can see. It's not really nested, but we have all of our different predict calls here.
Understood. Got it. Got it. Yeah, this still helpful. Understood. So
Yep.
sorry to digress. If you want to, kind of jump back to the code. You were at
I mean,
forward and you just showed us how it got executed.
yeah, the important thing when we do execute iteration, kind of the REPL itself, where is this?
It's in forward.
Wait, yeah. So when the REPL itself it's abstract, is that it can be this Dino implementation that we have. It could
Okay.
be an implementation on Modal, Daytona, E2B, Sprites, whichever sandbox you want to use. You can write an implementation for it. And as long as kind of it follows the protocol we've defined, which we're still working together with people to make sure that it's suitable enough to actually work. But as long as it follows this protocol, then it can work with any sandbox.
Understood. So for example, I use Nomad and Council and Firecracker. So that's the combination I kind of feel. So if I were to do this, I would have to write a small adapter sort of layer that basically passes the entire Python code and the requirement file sort of package so that it can run, right? That's effectively what it would be, correct?
Yeah, I'm not super familiar with Nomad and Thompson, but yeah, you need to be able to run the Python code that you're passed and maintain the state, and then call back for tools and call back when you submit things or when it's finished and ready to submit. So actually, that's another interesting one to talk about, is that when it's finished, it calls a submit function that we inject with all of the output names.
Got it.
So this has, the type validation in it for your actual signature that we inject into the sandbox.
Okay.
Or into
So
the interpreter.
just assume for a moment that the sandbox execution failed for whatever reason. Okay. So obviously the model is still waiting on for a response. Am I right? Because it'll be sequential, right? So what happens in this scenario? Like we send an error to the model which is waiting, or like how does it work?
It depends what kind of error. So if it's if the sandbox dies, for instance, then this wasn't in the initial release, but we've since fixed it. If the sandbox dies, just the whole program will throw an error, or it'll try to restart the sandbox. If it can't, it'll throw an error. If it's like the LLM wrote a syntax error when writing Python, then you just catch that, pass it back as the output of this step, and then the LLM will retry.
One more question. Do we pass the traces back, or we don't have to worry about it because the LLM would hold that with it, or it's still stateless? I think it should not be stateless, right? Because it is executing and it is on a pause mode, right? So when it's on pause mode and it's in the loop, it would have the, previous traces, or would you pick the trace and send back?
No, so we build the trace kind of on the host and then send everything to an LLM, and then like to a remote LLM. That LLM generates some code, and then we just take that code and run it in the REPL. So kind of our host machine maintains all of the history.
God, well, no wonder it was a lot of work.
Yeah, this was there's a lot of moving parts.
Yeah, I can now visualize it. Awesome. This was so insightful. You have anything more to add here?
No, I mean, I'm really excited for people to play with it, try and deploy it, see what goes wrong, what goes well. So
got it. No,
yeah,
I think this is a super helpful and fascinating tool to have in your arsenal. So for example, there was this small work that I did for equity research report. It was a POC, and a vast majority of that work is effectively taking these filings that they do with the SEBI, which is like SEC equivalent in India. And you take them, you summarize con calls, you summarize really long documents. That essentially is 80% of that POC. And I can see how RLM could have made that work so easy. So yeah, I mean, this is super helpful. So DSPy RLM based code, let's say I'm running on GPT-4 and I ran it on, let's say, Intellect 3, are there any sort of benchmarks that would Intellect 3 do better because it's primarily trained with focus on RLM as well, besides being a general purpose model, or any sort of numbers or intuition on that?
No, I haven't really played with Intellect 3, so I have no idea how good it is.
Let's move on to DSPy. I think we chatted about RLM a bit. So very simple question. Let's say somebody looks into DSPy and wants to be a contributor. How would you recommend them to start as of today? Yeah.
I mean, the way that I suggest getting into contributing is to fix or build whatever you think is fun, because that's the project that you will want to actually take through all the way to the end. So if you're using DSPy at work and you need to fix something, then that's one good way to start contributing. Or if you are in school and you think, hey, I want to do X thing with DSPy, then build it and show it off and tweet about it. And like people love to share DSPy content. So just build whatever you think is cool.
Okay. And what kind of bugs are the good ones to pick up if somebody is looking to?
I think that the bugs that are the easiest to fix are the ones that are more surface level. So ones relating to like adapters tend to affect a lot of systems, and so we don't like for new people to try and deal with
Okay.
adapters that much. Just because they're very
Yeah, makes
involved in
sense.
kind of every system.
Right.
But things relating to modules or how we handle some provider or light LLM, like those are very things that we can prove, hey, this is a small fix, it works, it fixes this bug, and then kind of go deeper from there.
Okay. Well, that's great advice. Okay. So I think somewhere around 2 weeks ago, I was trying to build a harness and I started using DSPy. So I started with a bunch of basic things like, you know, I build all these simple tools for read file, then execute like a very generic execute shell command if you want to execute anything, and sort of had a bunch of read-only commands that were allowed, like ls, pwd, and stuff like that. But as I kept on coding more, I kind of realized that there is so much boilerplate and code that you have to write to just get into the meat of the thing, which is about managing memory, is about writing code so that it can do some sort of continuous learning with traces. So, two questions. I've got to learn that I think DSPy wouldn't focus on this. So, do you see room for another sort of library to come in, which can focus on just the agentic flows and the kind of things you need to build an agent? Like, what's your perspective?
Yeah, I think that's totally possible. I mean, DSPy kind of, as a community, we want to be a thing that people can build on top of.
Right.
Like signatures are a really powerful primitive, and so we try and offer a bunch of really powerful primitives. And if it makes sense to kind of layer these into an agent framework, then I think that could work really well.
Okay. And you don't see DSPy sort of like DSPy 4 focused on AI agents, or do you think that will be always outside the purview of DSPy core library?
No, I think DSPy 4 is definitely going to focus on kind of agents and
Okay.
long running chains. But when it comes
Okay.
to things like building in file system reading tools, is that
Right.
something that I doubt that we will offer ourselves. And so kind of scaffolding out that boilerplate is something that another
Got it.
library can help with, then I think that's
Understood.
totally a greenfield
Got it.
area.
Got it. But if you look at it, anybody wanting to build a coding agent or any agent, right? Like pretty much most of the agents are offloading all their sort of memory related tasks to the file system, right? So shouldn't like a framework which is going to allow you to build an agent like come with some sort of utils folder which has all these basic sort of tools already in the library?
I think it depends what you mean by file system. There's a lot of people trying virtual file systems to replace memory, or kind of in these
Okay.
integrating with a
No,
file system gets complicated.
shell commands that interact with the Unix file system. ls, pwd, read file, grep, bm25 implementation. That's it.
Yeah, I mean, I think building those in a tutorial is probably where I would lean, and just say, hey, if you want to build a coding
Understood.
agent, then you can build off of
Understood.
the
Got it.
tutorial.
Do this. That's okay. I think you're the flag bearers of the library and sort of keeping an eye on the entire landscape and how it's evolving. But yeah, excited to see what DSPy 4 brings in. Now talking about that as well, how does the roadmap of DSPy gets shaped behind the scene? Like, can you sort of tell us how 3 got shaped? So that can give us some idea about how things work.
Yes, DSPy 3 had a lot of different pieces to it that kind of Omar was helping orchestrate with different contributors, different researchers, kind of everyone owning their different parts of the library.
Okay.
For instance, I really have never done much relating to building optimizers. That's not my specialty, and so there are other people who handled that whole purview. And so kind of DSPy 4 is looking similar in that each, there's a few different sub areas, and kind of each sub area has people that are pushing it forward and making sure that
Understood. So the gist is Omar is also the product manager here.
Yeah.
In a way, right?
He's
For the roadmap.
our fearless visionary.
Sorry? He's
our fearless visionary.
Got it. Understood. So, what's up with DSPy CLI? I'm seeing you're making a bunch of commits there. So what's in store there? Like, what are you and Drew cooking beyond what you launched with? Yeah.
So, kind of the gap that we want DSPy CLI to fill is that we want it to be really easy to actually deploy your DSPy programs and make them useful, and kind of that's something that isn't super self-explanatory. If you're in an enterprise, you have your own deployment mechanisms. But if you're deploying for hobbyists, it's like, how do you build a GitHub PR reviewer, right? You don't really need to care about scale that much because this is like a hobby tool. And so really kind of it's our answer for actually getting these DSPy things into the hands of a few users so that you can then figure out the problems. And then if you want to actually scale it up, then scale it up with whatever mechanisms you want.
Got it.
So kind of we want to help you scale your DSPy programs, make sure they're working, figure out what's breaking, and yeah.
So Drew already did a very detailed walkthrough on DSPy CLI. So I could see that you can build your APIs, and looking at your recent commits, I think you're focused on deployment as well, that you can easily deploy it on E2E, sorry, and some other sandboxes as well. So can we say that this tool allows you to productionize DSPy in real world much easily? Can we say that DSPy CLI kind of does that?
Yeah, I'm gonna hedge and say that if you're an enterprise, DSPy CLI is probably not how you should do your deployment. But for a lot of people who are building kind of smaller tools, yes, it's absolutely the way that you can get your programs into production.
Got it. Bootstrap DSPy based projects quickly. I think that's
exactly.
Got it. Isaac, thanks for spending time with us today. And it was fun talking about RLM and you walking us through how it works. Congratulations to you on launching it. And it was awesome to have you.
Yeah, it was super fun chatting. Thanks for having me.
Thank you.